it occurred to me looking at, I put up this just for, to have something to look at while you guys were waiting. And I realized, actually my talk handles a chunk of the Bio-IT World logo. So we've got a DNA helix. We're going to talk about that. We're going to understand what a DNA helix is about. We're going to talk about the zeros and ones. How do we get to data from that helix? We're going to talk not so much, I'm going to take the bar graph as representative of analysis in general, so we'll talk a little bit about that, and eventually tie it back into the green block, which is human health. Why do we bother? And it occurred to me, I've been coming to Bio-IT World for quite a few years on and off, and it's bio and IT, and I come from the IT side of the house, and I realized I really didn't know much about the bio part of that phrase, bio. My training, I have a degree in philosophy, so I do not have training in molecular biology, which is what we're going to talk about today. So this is coming to you from a fairly layman's perspective, and so you don't need to worry that hopefully I'm not going to kill you with detail. I have good news and bad news too. The bad news is the slides that are printed in the book you can just close. They're completely different. So the good news is that the slides are much more improved from where they were. So let's get started. I just want to tell you briefly a little bit about where I come from. I work at the Jackson Laboratory. I've been there, 16 or 17 years. We are doing basic biomedical research, nonprofit, grant-funded, mammalian genetics. And we're basically trying to find the root causes of genetic disease and help find solutions to them. The lab is in a beautiful location up in Mount Desert Island off the coast of Maine. We're always recruiting, so if you want to come somewhere beautiful, get away from the city for a while. It's a gorgeous location right next to Acadia National Park. It's been around for over 75 years. We have about 38 principal investigators. Close to 1,350 employees, roughly $200 million a year budget. We have a one remote site in Sacramento, California, and we've been in the news lately because we're looking at a potential site in Florida. And the lab is not just about research. I mean, it's research programs. Clearly, the sort of the key focus of the lab is research programs, but we also are well known for our services to other researchers, primarily in the form of research mice. We're the gold standard for research, high-quality research mice. And the mouse is used as a really important platform in looking at genetics, the basis of genetics. And then the IT staff we have a central IT group, which I'm a part of, about 50 people. And my job there, I've ran infrastructure for the lab for 14 years. And then just recently I've transitioned into this role of trying to be someone who helps communication between our scientific faculty and the IT department, because that, when left to its own, doesn't always go so well. They don't talk the same language, and they're not always proactive about communication. So hopefully today, especially for the IT folks in the room today, I want to help give you some understanding of the background of the genetics piece of it, so that when you're working with faculty, with scientists, you have some concept of what they're talking about. So we're going to start off with science. We're going to start off with what's called the central dogma of molecular biology, to understand really what's the core set of questions that biologists and geneticists are asking today. We're going to then find out, look at how high-throughput sequencing works, and try to figure out why is it that